Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I think you should go.
Okay, I think we can get started. It is my pleasure today to introduce Dr. Francois Guimbretiere from the University of Maryland. Francois is an assistant professor there in computer science and the Human-Computer Interaction Laboratory. We've been fortunate enough to be able to work with Francois for many years. I watched his bright career start before he got his PhD, and then several years now as he's been working as a young professor. So I'm sure he's going to tell you about lots of cool gadgets and his merging of pen, paper, and computers. Francois?
Thank you, Mary. So thank you for having me today. And today, as Mary pointed out, I will present my work on people, pen, and computer. The basis of my work is that for the last 25 years, people have predicted the disappearance of paper in an office environment, like this person in the center of this picture. But clearly, paper is dying hard, and we still are using paper extensively in many of our activities. The main focus on my research is to try to understand how this new technology I've presented here can help bridging the gap between the ease of use of paper and digital media. So in clockwise from the top left corner, there is this new digital pen from Logitech, which can record all the marks you make on special paper. I'm sure you recognize the device on the top right, which is a tablet PC. And there is also a couple of research projects I participated in on the lower part of the picture. Today what I will do is I will present two projects, or in fact three projects, which has been made possible by the partnership between UMD and Microsoft Research. And this project involves a device on top of the picture, which is a tablet PC and the digital pen. This partnership was very useful for us because not only it provided financial support for me and my student, but also it gave us very easy access to research done here at Microsoft. And as you will see, there is a lot of work here which has been done either in relationship with a group by the Mary's group, or by the work I've done with Ken, with whom I've been interacting or collaborating for something like 3 years now. So I think this legal framework provided by this partnership is really important because we can get a kind of head start on key new development in research, which is very important for a field which is moving forward quite rapidly. Okay, so today I will first start with tablet PC interaction, and then I will discuss with my work on paper-based interaction. So I didn't create this slide. In fact, it's a slide created by Ken, which I think expressed clearly the problem we have currently with the tablet PC. It's a great platform. It is great to be able to interact with a pen and to take note with a pen, but unfortunately, it seems sometimes that the pen is stuck to a brick and it's very difficult to interact with the interface on a tablet PC. The reason behind that is very simple. The interface we are using on a tablet PC has been designed for a very different configuration, a configuration shown here, where in fact you have a very stable environment, you have access to a very stable pointer, which is a mouse, which also provides you with very accurate movement because there is a gain control inside the mouse. And of course, you have access to the keyboard, which is very important for expert user. I should also say that this environment prevents any occlusion because your hands are not directly on the screen. So now if you move toward an environment which is the tablet PC, it's basically the complete opposite. It's an unstable environment. You don't have a keyboard, so you cannot have shortcuts. You are working directly on the screen, so you have occlusion. And also, because you are working directly on the screen, the resolution is limited by the resolution of your movement on the screen, meaning that you don't have any way to play with gain control between your input and the movement of the cursor on the screen. Okay, so what was our solution for this problem? you first have to understand that you have two problems to solve if you want to move toward a new interaction model which is more pen-friendly, if you wish. The first thing is that you have to understand how you can make the interface framework, which is what is on the periphery of your screen, like a menu, like a toolbar, more pen-friendly. So that's a very important aspect for the interface, and it's in particular very important for people which are either novice or intermediate user. But you cannot only think about that, you also have to think about what happened on the document area of your screen, because that's where expert user will spend most of their time. And when you look at expert user on the desktop, they will rely extensively on shortcuts. So since in a normal tablet configuration, you do not have a keyboard, what do you do? So I will discuss these two problems in turn, first starting with the interface framework, which we deal with by a system called CrossY, and then describing the document area aspect of things, which was work I did with Ken called Scriboli. Okay, so CrossY, as its name implies, it was all about crossing. What we did is we moved from the basic interactor in a normal desktop environment, which is clicking, to an interactor which is more natural for pen, which is making small pen stroke on target, which are presented on the screen. This idea came, in fact, from different direction, one of them being the work done by Apitz and Zai, which demonstrated that crossing can be as efficient as clicking in most situations. So we were very interested to see how we can move from this empirical finding to a full application which will be using crossing extensively throughout the interaction. And our main question was how expressive is CrossY? Okay, so let me show you the video. As soon as I find my cursor. Okay. Oops. Can we raise the sound for the video, please?
The point-and-click interface restricts interaction to a series of discrete steps, like here, where we change the attributes of the pen step. In this video, we present a new interface based solely on crossing. In our application, named CrossY, basic interaction steps are strokes made through crossing widgets. These steps can be fluidly composed, as here, when we select the color and width of the pen in one stroke. In the next scenes, we display the normally invisible pen strokes on the widgets. Our system uses a tool palette with 5 buttons. Each tool, like the highlighter and the eraser, can be selected by crossing them from right to left. Other kinds of buttons are provided as well. To access them, we open the pen dialog box by extending the stroke outside the pen button. Here we see several radio buttons. We cross them from right to left to select the characteristic of a pen. As shown here, the layout of our windows makes it easy to select several attributes in one stroke. In CrossY, the left and bottom borders of dialog boxes are used to validate the selection, while the top and right borders are used to cancel a selection. This makes it easy for the user to call the dialog box, select the parameters, and validate in one stroke. We also offer checkbox functionality, where several options can be selected at once by crossing them vertically. When only one selection is needed, the user can select the checkbox by crossing it horizontally. Our system provides other types of classic widgets, such as the slider. In our brush palette, we use 2 sliders to set the color and width of the stroke. To pick a color and width, the user may simply cross at the corresponding positions on the sliders. Again, several parameters can be selected in the same stroke. To open a file, we use the Flow menu to call the File Open dialog box. Here the user moves the pen up and down the file list, where the current selection is always highlighted in the middle of the dialog box. To let users navigate, we only present unique prefixes. After a prefix has been selected, The user can complete this prefix by a simple horizontal movement. Moving the pen to the left leads backward in the directory tree. Once the desired directory is selected, another movement to the right opens the directory. When the target file is reached, another movement to the right opens the file. Different gestures on top of a crossing element can result in different actions. Our scroll bar, for instance, allows users to move to a specific location on the document by simply crossing the scroll bar at that position. After crossing the bar, the user can continue adjusting the position with varying gain. Also, the user can move one page up or down using different gestures. Furthermore, it is possible to repeat the last movement by simply crossing the bar again. A crossing interface, such as CrossY, makes it easy to compose several commands in the same stroke. To illustrate this feature further, we'll now demonstrate CrossY's Find and Replace function. In the upper panel, one first selects the target width and color, and then in the lower panel, selects the replacement attributes. Crossing allows the user to compose these actions in one gesture. We can now search for an item and replace it. For the next match, we can decide to change the replacement values. With a slightly modified gesture, the user can search without replacing. Replace again, or we can undo replacements. In this video,
Okay, so we'll stop here. Okay, so by the way, if you have any question during this talk, don't hesitate to ask me directly. Okay, so as soon as my cursor comes back. Okay, so as I was saying, our work was based on theoretical work by Acot and Dye, but it was also based on several examples, like for example work which have been done by Patrick Baudisch, which is working with Ken Hinckley, and also by a small example in Lotus Note. The main idea though is that these examples were just addressing one problem inside a larger environment, which was a click and base interface. And CrossY was able to demonstrate that we can do most of the action performed on a normal window interface using simply CrossY as the main interaction. Let me go now in more detail about a couple of points which are important for crossing interface. So you have seen that the basic interactor, what will be the equivalent of an OK button in a point-and-click interface, is a simple target on the screen. We have also different kind of button, like a normal window interface. We have option box and checkbox. So it's important to notice that, in fact, when we designed this option box and checkbox, we were careful to reinforce the semantic of the selection in the layout. So on the top of the screen, you have a set of choice which are mutually exclusive, so we stack them vertically. So it's very clear that it's difficult and in fact impossible to select several choices at once. On the other hand, for the checkbox, we slanted the target so that you can either select one box at a time if you wish, or you can select a set of box at the time also by crossing them vertically and then selecting them all at once. You can also do composition, of course, like going, for example, down for the first two and then turning left. So yes, turning left so that you can select the OK button. Talking about the OK button, you notice that in fact there is no visible OK button because the border of the window are either OK for the bottom border and the left border, or cancel for the right border and the top border, and they are highlighted in green. I don't know if you see it very well on the screen. And the idea here is that if we can put them as a border, then it really encourages people to go through in one stroke and cross the options they want and the OK button in one interaction. Another important aspect of today's interface is, of course, the scroll bar. And here I describe the standard scroll bar that I'm sure you are all familiar with. One of the key aspects of the scroll bar is, in fact, the different actions in the scroll bar are spread on different locations on the scroll bar. So, for example, if you wish to move, you first have to access the absolute movement area, which is a cursor, and then move the cursor to where you want. So that's certainly a problem. And what we try to do is to see how the crossing interface can help us simplify this kind of interaction. To do so, what we did is that we started to use gesture on top of the crossing widget. So as you have seen in the video, for example, if I want to go one page up, I just have to create this small gesture which looks like a triangle anywhere on the scroll bar, and then the scroll bar will automatically go one page up if I go upward, or one page down if I go downward, and I don't have to reach a specific area of the scroll bar. If I wish to repeat the scrolling, it's very simple. I don't have to wait for a timeout. I can simply extend the gesture by recrossing the bar, and then automatically the system will start to scroll upward or downward. Again, the important aspect here is that, of course, you don't have to wait for a timeout so that you can perform this action very rapidly. The same kind of idea applies to cursor control. If you want to move at a given location in the document, you simply go there, cross the bar, and right away we jump the document to this location. Then you can either adjust your movement in a coarse resolution by staying close to the bar. But if you need to kind of move line by line, for example, in a very long document, we provide an option for you to do so by simply moving away from the scroll bar, and the further away you go, the more fine adjustment capability you have. So this is an idea which has been developed a little bit by a system called Fine Slider, and then we integrate that into the crossing environment. As described in the video, in a crossing interaction, you can either do the same thing as what you will do in a point-and-click interaction, which is select each command or each option one by one. But what you can do also is compose these different actions in one fluid stroke. Again, notice that the fact that the OK button is on the left really simplifies the movement. You can just do your stroke, exit the dialog box, and the dialog box is dismissed and your selection are validated. Another aspect which is quite interesting in crossing that you don't have in point and click is that the direction of the stroke can also influence the semantic of the action. So this was illustrated in the video during the find and replace utility, where when you basically go through these two iterations counterclockwise, you perform the operation. But if you go clockwise, then you will basically perform undo. So what do we learn when we design CrossY? The main lesson we learned that it is possible to design an application which is solely based on crossing for its primary interaction mechanism. The system was very well received when we demonstrated it at the HCIL Open House and also at WIST. And what we discovered while looking at people using this system is that basically for the basic interaction, the crossing interface is more or less a plug and play compared to the point and click interface. On the other hand, when you want to use the advanced feature I discussed about, which are, for example, the fact that you can stroke several targets in one stroke, or the fact that you can use advanced set of gesture on each interactor, then you have to be slightly more careful about the design. So for example, if you want to use several commands in one stroke feature, what you have to be careful is to be sure that you don't crowd your window, because people, when they do this stroke, are a little bit sloppy, and you don't want that they trigger some interactor by mistake. If you want to use the gesture feature with the overloading it provides, you have to be careful, because there is a trade-off between the feature you provide and the fact that people may have difficulty discovering that this feature do exist. We think that it will not be a problem in the long run, because what happened is that if your system is very regular, people will learn this feature. Like, they will probably learn very rapidly how to use a scroll bar. And then if every application in the system uses the same kind of gesture set, it will be very easy for them to remember this gesture. Of course, you can also alleviate this problem by providing system like tooltips or system where you have an help gesture. When you kind of draw this help gesture, the system will draw all the gesture available for a specific interactor. I should also point out that, in fact, this problem do occur in normal point-and-click interaction. For example, if you look at any complex application, it's often very difficult to remember exactly what each small tool in a toolbar do. And what people do is that they go and they wait for the tooltip to present what the operation will be. And you can do exactly the same thing in a crossing-based interface. Okay, any question on this part? Yes?
So the good part of this here is that on the one hand, we've made interaction for users on a tablet PC much easier.
Mm-hmm.
I guess the bad aspect for the users is that they have to master now two metaphors, one for the desktop and one for the tablet. And also for the application developers, there's an added complexity, because if you have an application that you want to live in both spaces, right? So what I'm asking is there any hope of the desktop and the tablet interfaces converging? And are there any easy fixes to the desktop? For instance, if you just make those widgets giant, does that translate?
So let's see. So we never explored that, but we believe that it is possible to design a system where you can do both, so that you can have crossing and clicking at the same time. Because you can have you can design your buttons so that you can click on them or you can cross on them, and the system will understand that the same way. So that's one way to kind of make a transition from your desktop application back to your tablet, and from your tablet back to your desktop application. The problem, of course, is that if you start to use too much gesture, it will be very difficult, because when they go back to their tablet, to their desktop, they will not have all this gesture available, and that will probably be some kind of a limitation. But it is certainly a concern, and again, we think that it's possible. We haven't studied that, so I don't want to have too many claim on that. But we think that it's very possible. About your second question is that is there an easy way to move a desktop from the desktop, or more specifically, is there an easy way to move from the desktop interface to a tablet interface? The question, I think, is no, because it's really the desktop interface is very, very powerful for the kind of interaction it has been designed for when you have a mouse and when you have a keyboard. But I think we should, if we try to modify it a little bit and a little bit and a little bit, at some point we will reach diminishing return. And the best option, if you ask me, is to try something else that will work well. I know that it's not a very commercial argument. I know that in Microsoft you have many users, and all these people, they don't want to kind of throw away what they learned for the last 20 years. But on the other hand, my work is consider what can be done, not what is practical right now. Which I know is not a very good answer to your question, but it's an easy way for me to get away with it. Yes.
So maybe a related question, jumping off question is, did you do any user testing with this, and what's the learning curve?
So we haven't done that yet, but we are planning to do it. So in fact, we have a student which is starting to kind of work on, again, crossing interface. And one of the main goals of that effort will be to do testing to see how, you're right, how the system can be used in the long run. Yeah.
Is everything just the same if it's a finger-based interface, or does anything have to be tuned differently?
Yeah, so the problem with finger is that your fingers are very big, and they will mask, in fact, a lot of information when you do the interaction. Another problem with finger is that it's very uncertain where the real contact point is. And so you will have to be careful and probably have targets which are bigger. You can probably ask Amy about this problem, because she presented some data yesterday about that.
Is it as simple as just make everything bigger and then it works for the finger? Or do you think, yeah, it's a third the third world?
I think, I don't think people like to, people don't really like to do that with their finger. For one, is in fact, if you have a screen, finger don't really like to move very well. If the screen is, every surface, finger has a tendency to kind of stay where they are, except if you make a surface that will let them slide. So I don't think, in fact, I will recommend using your finger to do a crossing interface. It's probably pointing and just clicking will be probably better. Any other question? Okay, so I press on this button, unfortunately, so now I'm already on the next slide. So I've talked about the framework, and now what I will talk about is an interface for the document area where, in fact, as I say, most experts will work, and if they use CrossY, they will have a problem because, in general, they rely heavily on their keyboard shortcut. And of course, in our case, there is no keyboard shortcut. So since there is no keyboard shortcuts, what will happen if you want to do something very simple, like copy this word from one location to the other, you will have to do a little bit of gymnastics with your pen. The first thing you will have to do is switch mode so that you move from the pen to the lasso mode, which is here. Then you go back, then you circle, then you go back, you say copy, then you go back and start to move the object you want to copy, and finally you are done. Okay, so that's a lot of movement for something which is very simple, and you can imagine that people will do all the time if they were to manage their unwritten note on the tablet PC. So first, what is the root of the problem here? So the root of the problem is that computers have to parse your input, and they have to make sure they understand what is intended as stroke, as inking, and what is intended as command. And in normal interface, what they do to do that is they do two things. The first thing is they say, there are some area of the screen which I know for sure that if you do something there will be a command. So that's basically all the periphery that you see, and that's what CrossY is all about. And then the second thing they do is they say, when you pick a tool, you have to remember which tool you pick, because I will maintain this tool until you pick another tool. And that's kind of problematic because, of course, people forget. And in the desktop interface, it may be okay because people are very focused. But in application like note taking during a meeting, people are interrupting you. You do other things. You think about what the speaker is saying. And this mode can be really troublesome. In fact, I have a colleague who say that once she was trying to take a note while the mode was eraser, and she started to write, and she started to erase a lot of information, and was very annoyed by that. So it's certainly a problem. So now that you have these two mechanisms, it's relatively easy to work with. What you do is that you first select a tool so that you select the scope, which is the object on which you will work. Then you again select another tool where you will be able to select the command. And then finally, because this object is selected, he has a special property, he has a special property on the screen, and now you can drag it. But again, that gives you that kind of solution, which is not really convenient. Okay, so while we were working on CrossY, Ken Hinckley and I started to discuss about, is it possible to have the same kind of idea inside the document area for experts to interact very rapidly with the information they are manipulating. And the idea was, okay, can we have speedy interaction without a keyboard? And can we have an interface that will, in the long run, reduce the cognitive footprint of the interface? And by that, I mean, if you know how to drive a shift stick, you know that in the beginning it was this thing. Okay. You know that in the beginning it was very difficult for you to learn, but after a while you're able to shift gear without thinking about it. You can talk to people, you can listen to the radio, and it doesn't matter. So can we design an interface for a tablet PC which can just do that? One of the key points of the research was not only can we do that, but can we do that so that it can deal with relatively large and complex application, and also different application domain. Okay, so that's kind of a non-trivial endeavor. In fact, a lot of people have been working in this general area, and I think the system we look at more closely is gedit by Kurtenbach and all, which we're trying to solve similar problem, but in fact was something that I think we can describe more like a small scope application trying to demonstrate key capacity of pen gesture. What we try to do is start to learn from this system and then develop a system which can scale upward to complex application. I should also say that in this kind of work there is, I'm sorry about that. In this kind of work there is two camp, if I may say that. One camp is about avoiding recognition, so having, for example, a structured gesture system so that the system will recognize with minimum error what the user intends to do. And another camp which is focusing more on recognition approach. And while looking at the literature, we said that recognition approach is very useful, but unfortunately, we feel that it's not accurate yet enough so that to deliver a reliable interface to users. And if you really want to limit the cognitive footprint, you really have to have an interface which is reliable, because if you have to check if the interface did what you wanted, then it cannot reduce the cognitive footprint. If each time you switch gear, you will have to check somewhere that you are really in third gear, that will not really help you learn to switch gear very rapidly. Okay, so what did we do in CrossY? So the first decision in CrossY was to separate inking from command. We have a button which can be on the pen or can be on the side of the tablet, and the latter is the preferred solution. When you press the button, everything you do will be interpreted by the system as a command. Okay, so then you can start circling. Then the next thing is we have to know when you are done selecting the scope and want to start selecting a command. And to do that, we used something called a pigtail, which is a very small E-like gesture where the strokes self-intersected. It's relatively easy to detect from a computer perspective, and it's something which is very easy for human to do because we all learn how to write, for example. So it's something that you can chunk in your muscle memory. Then when you have selected the command, here we selected the copy, you have to tell the system, okay, I'm done with the command selection, now I want to move on to parameter selection, meaning that I want to move the selected item somewhere else. And to do that, we use crossing, where you just have to cross the boundary, the bow, which is described on the screen. And as soon as you cross the boundary, we move from command selection to now direct manipulation so that you can move the word Scriboli. And then when you leave the pen, the system go back automatically to the ink mode. Okay, so the end result of that is that in one stroke you were able to select the object on which you want to work, select a command, and then perform a direct manipulation task. And the system, as I pointed out, is quasi-modal, meaning that in fact, you have to maintain a physical, muscular tension by pressing on a button to keep the system in the command state. So it's the difference between having cap lock and shift. And most people use shift because you are sure that you are not going to forget that you press cap lock. Because when you use shift, you have always to press with your pinky. And that pressure reminds you that you are in command mode or in shift mode. Okay, so so far so good, and in fact one of the previous system I designed, which was a mural, has a very similar approach of one stroke to select the object, select the command, and then perform the interaction. But of course this one stroke policy has a lot of limitations. So for example, if I want to select the two blue Scriboli here, if you have a one-stroke system, you have to do something like that. And of course, this one is not too complicated, but you can imagine that it can become very complicated to try to select several objects in one scope, in one stroke, and sometimes it can just be not only complicated but impossible. So clearly what we would like to do is to have a system which lets you have several strokes to construct one command. Okay, so what shall we do? It's very simple. What we decided to do is that starting from the model used in Scriboli, where the quasi mode, I'm sorry about that, where the quasi mode is initiated by pressing the button, and then it is kept by having the pen on the screen. So that was, many systems used this approach because it was believed that in fact that is the most natural approach for a user because they don't have to be bothered with holding the button down. And it's in particular a very practical approach in the case where you use a pen because pressing a button on a pen is sometimes difficult. So, but in our case, if you remember, we said that the button do not have to be on the pen, it can be on the side of the tablet. So in that case, it makes sense to say maybe what we need to do is to ask the user to keep the button pressed as long as they wish the command to be, the stroke to be interpreted as command. And in that case, it's become okay to leave the pen as many times as you wish when you execute a command. Okay, so what does that give you? So the first thing that gives you is that you can start to have very complex scope. So you can have very complex selection. You can have selection where you can just point on an object. You can have a selection where you can circle several objects. You can use this crop mark if you wish. And you can also cross through object if you want. And that's in fact an interesting aspect of the system, as I will demonstrate right now, where using this crossing mark, I can not only say I want this object to be selected, but I can also say, remember the special position at which I cross this object. So for example here, imagine that I have this letter and I just want to align them. What I will do is I will stroke them at different positions that will be used as the reference line for alignment. And then when I'm done with E, I will simply write down align, and as you can see, all the letters will be aligned with using as a reference point the point where I cross them through. Notice that such alignment is in fact very difficult to do in an application like Illustrator or PowerPoint. But here, because we can have this complex scope mechanism, it is relatively natural to build this complex alignment mechanism, and it also requires only one align, because what you just say to the system is just align, and then they use a different mark you make to kind of align them on the same line. So it's very different from PowerPoint or Illustrator, where you will have a list of align, bottom, top, left, right, and say or middle. Okay. Okay, so the second thing which is very important is that when you let people have several strokes during the command creation, you can also let them have several strokes when they select a command. And that's very important because in our system we were using marking menu, and marking menu, when you have more than 8 options, you have to use what's called hierarchical marking menu, which in general have a higher error rate than normal marking menu. But recently, Zhao introduced a variant of the marking menu, which is simple marking menu, where if you want to create complex command, you keep marking simple mark in one direction, each mark in one direction. Of course, you cannot do that simply if you don't have the opportunity to say, oh, it's okay to have several strokes in a command. And what they did, in fact, in their implementation, was they used a timeout to make a distinction between, after a certain amount of time, they are probably done selecting the command, so I can switch to another mode. Our approach let us remove this timeout, which is always a good thing because you never know exactly when the kind of length that the good timeout should be. And finally, since you have now several strokes per command, it is possible for you to do adjustment. Again, if you remember, if I have one stroke to do everything when I move an object on a screen, it means that if I make a mistake, I have to redo everything. I have to reselect my object, I have to reselect the command, and I have to move the object again. That kind of pattern, which have been used extensively in the Stanford Interactive Mural, is make the life of the user very difficult if they want to nudge a little bit a given object. With the solution we propose, in fact, you don't have this problem, because if you want to nudge a given object, you just keep pressing your finger, the button, and then you move the object at your pace. And then when you are ready, you remove the finger from the button, and then the command is finalized. Okay, so what we learned from this project, we learned that in fact Pictel work very well, and it has performance which are similar to the technique which is compete against, which is this technique called the handle technique, in which you create a small area at the end of the selection on which you will be able to start the marking of the command. I will not go through much detail, and I will recommend you go through the Chi-05 paper Ken and I and others wrote, so that you can see the pro and cons of the different technique and the difference in performance also. About the full tension, which is the fact that you can have a button on the side and keep pressing this button through the command. We did some user testing, and we discovered that it was well accepted by users. They didn't mind the fact that they have to press through the full scope of the command. And we also demonstrated that it can probably be implemented with something like a touch-sensitive strip, which means that then you don't have to have one button, but you can have an area where it's okay to press for you, which really helped, because if you have used tablet PC, you will discover that in general, the buttons are in a specific location, and this location may not be convenient for you. I mean, maybe it's convenient for other people, but if you have smaller hand than expected or bigger hand than expected, it's quite inconvenient. So our result of when this experiment was that, in fact, the performance is similar. The problem with the touch-sensitive strip is that people, in fact, were uncomfortable, because it's sometimes difficult to know when you press hard enough to trigger the mechanism. But we think that, in fact, it can be solved very easily by introducing a little bit of tactile feedback in the system. Okay, is there any question at this stage for this part? Yes?
You mentioned earlier that the button on the computer is comparable to the button on the pen. Could you just talk about that a little more?
Yes, so in fact it's work which has been done by Ken and people at UW, by Lee specifically. And what they tested is the difference between if I ask you to select a command using a marking menu, and the difference between you press on a button which is on the side of the computer, or you press a button which is on the barrel of the pen. And they demonstrated that the solution where the button is on the side of the computer is faster, and I think the error rate is also smaller. Do you remember, Ken?
It's like a 1% error rate.
Yeah. Yeah, I think that seemed to be the best solution for this problem. Again, the problem though with this solution, as I pointed out before, is that you have to figure out where you put the button, which is a non-trivial problem. Yes?
So this seems to work really well when the commands either precede or post-seed the operation,
Yeah.
continuous operation. But in a lot of graphics apps that I use, the modifier keys like Shift, Control, and Alt are used intermittently during the gestural
Yeah.
input. So when these apps are translated to the tablet, they fail. They don't work.
Yeah, we didn't look into that, did we? With the fact that you can change on the fly.
Yeah, we didn't. I mean, we're just trying to tackle sort of simpler things in the first place.
Yeah, so I think it's a big mountain that we have to climb, and so. But you're right. I mean, it's certainly something that we should consider to be able. I use Illustrator all the time, and it's true that this modifier key that kind of let you change rapidly the mode during the manipulation are very useful. I think in our case, we can probably do it if you have different button. But again, it's the same problem, is that then you have different button, then you have to deal with different button, and a lot of problem occurred, in fact, which are more and more hardware based, which is how do you more kind of industrial design. How do you design a tablet where you can provide this feature, for example? Because it's a non-trivial problem. Because tablets are really, the manufacturer tried to make them as small and slim as they can, so they don't have a lot of space to kind of play with, fancy device, or add more and more buttons. And buttons are expensive. In fact, that's a sad fact of life. Is that making more buttons on the device is in fact very expensive. Any other question? Yeah.
You talked about tactile feedback, and we also looked at least 3 different pen contexts.
Yeah.
And I was wondering if you've done anything with reflecting context with the state of the cursor, a cursor perhaps on the pen, or even reflecting the button states to the screen.
No, the main reflection is that when you press, the stroke will become red. So you will see right away that it will, you are in this spatial mode, which is the command mode. But we didn't do, I think our main approach is we wish that there will be no need for cursor. Because you don't need a cursor, right? When you write on a piece of paper, there is no cursor and you kind of do fine with it. So is it possible to design a system without cursor? But you're right that in some situation, when you kind of start to have complex operation, you will need a cursor. In particular, if we address your problem, which is, we change the state of the system as you go through an interaction, it's clear that we have to make clear to the user what will happen.
Even for simple operations, you talked about your friend that a mistake erased.
Yeah.
I wonder if that would have been avoided had she been able to see, oh my God, there's a big eraser block.
The research shows that in fact people, you can give them all the cursor you want. If they are really focused on a task, they will just do what they think they are doing, and it doesn't matter what you show. I mean, the best example is VI. So VI is our key example about mode bad. And you discuss with people about VI, and they say, oh, but it's okay because there is this insert word here that clearly tell you that you're in insert as compared to command mode. And in fact, I used VI a long time ago, and I never look at this down word. I mean, I have other thing to do. I'm looking at my text, say, for example. And you forget. So what you do is that you keep press escape so that you know where you are. And that's basically how people solve. And
just to add to that a little bit, like we've definitely done studies where we have cursor feedback, and like some people will rely on that, but a lot of people will like never notice that it's there, and the pen often tends to block it depending on how you hold it. So cursor feedback on a tablet is actually much less useful than you might think at first. So it's nice to have it, but to rely on it is not a good idea.
Do you know the pen angle? I mean, if you were going to do feedback, you would guarantee that it's not under the pen.
Well, you know the pen angle, but you don't know where the user's viewing angle.
yeah. No, it's tricky. The fact that you are on masking a lot of stuff, including the pen, is masking what you are doing. It is certainly tricky. Yeah. Any other question? Okay, so now I will move to another part, which is the part about paper. So you may be wondering exactly why a computer scientist is focusing so much about paper. So the answer is very simple. Here is my desk. Or I shall say a clean copy of my desk, because my desk is really messy, and this thing is just a kind of a nice rendering of my desk. And as you see, I use paper extensively. So yet I also use computer extensively, and I really wish that I can move information from one medium to the other in a very fluid way. So I'm not the first person to think about that, of course. And as you see here, a lot of people have tried to tackle the problem going from one extreme, which is a digital emulation of paper, a system like Ex Libris, or I guess Anoto will be a system like that too, to a system where we couple tightly paper and computer, for example, by projecting some information on a piece of paper on which you interact. That will be the digital desk system. Or to system where paper is really a kind of second-class citizen, which is mostly used to enter information into a digital computer. So that will be, for example, the Anoto system. So what I wanted to do instead was something which I call cohabitation. And the main idea behind that is that I should not, as a designer of the system, take side between is paper better or computer better. What I should do is help user move from one medium to the other as they want. So for example, if I create a document, I will probably start creating the document on my computer. Then after a while, I will be happy with the document. I will print it. Then I will start to probably wish to annotate or discuss or navigate through the document, and in general that's done best in the paper world. When I'm done and synchronize my pen, and all the information I capture in the paper world will come back into the digital document. So that the previous slide was the concept of the system. Here is the design of the system itself, and what we do is very simple. Each time you print something, we are taking a snapshot of what you are printing, and then we also record the correspondence between a digital paper page, a page of paper on which there is a pattern on it, and the page of the document that you are printing. Then you can go and use a pen like that, like this Anoto pen. In fact, I can probably circulate that. You know that, Mary? Okay. So then you do the annotation with the digital pen, then you synchronize your pen, and everything, upon synchronization, we just fetch the initial, the original version of the document, bring the stroke into the document, and then you can complete the circle. Okay, and so here's the key technology enabler, which is you have to have a system like the Anoto pen where you can not only record where you write on the page, but also which page you are writing on, and hopefully with a very large space of address, because if you imagine that everything you will print will in fact be on different address, you really need a lot of address to do that. There are many different technology, including Anoto and DataGlyph, and in fact the UPen, which has been developed here at MSR China. We use Anoto mostly because it's the currently commercially available system. Okay, so here's one of the first example of the system called Paper Augmented Digital Document. And as you see on top, there is a printout which has been annotated, and on the bottom there is the result after we synchronize and all the strokes have been brought back from the paper world. And you see that the accuracy and the look and feel are very similar, which kind of comfort the idea that the system will work and will be well accepted by the user. So of course there is a problem with the original pad system, which was, it's true that people do annotation, but most of the kind of information we collect on paper is not only the annotation, it is the semantic behind the annotation. So if you look at people trying to do a synthesis of a document or a different document, what they will do on their note, they will start to make reference to other document. They will sometimes do physical collage from a paper document to their note, or sometimes they will try to kind of reproduce some kind of piece of information from one document to another. Of course, all this information will stay in the paper world, and it will be very difficult for them to try to search all these links they have created while they were doing all this manipulation on paper. This situation is of course very different from the situation you have if you were to use OneNote, where when you use OneNote and, for example, you copy something from one document to the other, OneNote is able to remember the original document from the web, for example, so that you also create a direct link to the original document. So the question we ask is, given that people like paper so much, for example, when you're on paper, you can have many pieces of paper around you, and you are not limited to one screen. Can we do a system in which the kind of interaction you can do on OneNote will be possible? So for example, I will be able to copy something. So I have a document here. Then I want to copy these figures. So I make this mark, which are this quote mark and this copy mark. Then I go back to my notes, and I will make now the paste mark. And then when I synchronize my pen, I will see my note on my computer, and I will see the image which was from this original piece of paper, plus I will have a link. So if I click directly on this image, I will go back to the initial document. So this work was done by one of my students and in collaboration with Ken. So let me show you a video of this system. Oops, sorry. Somehow my mouse doesn't work anymore. Oh, here we are. Okay, sorry about that.
Paper is used extensively by knowledge workers during knowledge gathering and crystallization. Using paper, users can navigate through several documents by spreading them on their desks and annotating them with ease. During their work with paper, they create a rich web of inter-document links by including references in their notes and sometimes by creating collages. Unfortunately, links created on paper are difficult to transfer back into the digital realm. While digital solutions such as OneNote can capture these links, they are limited by the size of the screen on a standard tablet PC. In this video, we present PapierCraft, a system that lets users manipulate digital documents using paper printouts as proxies. To copy an image, the user selects the area of interest with a pair of crop marks and then draws the copy mark. Back on the user's notes, the user draws another pair of crop marks to indicate where the figure should be pasted and then draws the paste mark. Upon pen synchronization, the operations performed on the printouts are carried out on their corresponding documents and their results can be seen on our document viewer. To distinguish between normal annotation and commands, the user presses the command button, a simple foot pedal in our current implementation. While the pedal is pressed, gestures such as this margin bar will be recognized as part of the copy command. With another gesture, the paragraph and its annotations are pasted in the user's notes. Both a snapshot of the selected paragraph and the user's strokes drawn on top of it will be available inside our note viewer. As a convenience, the viewer also provides access to the underlying text. PapierCraft commands may also have several parameters. Here, a user first selects a paragraph and then underlines an indexing keyword before drawing the copy gesture. Upon pasting, the selected paragraph will be tagged with the underlined keyword. PapierCraft commands may also span multiple documents. For example, one can pin two pieces of paper on top of each other by using the stitch command. The tip of the stitching marks is the position of the anchor. To make it easy to extend the PapierCraft command set, it is also possible to write the name of the command one wishes to execute. Writing the name of a command always overrides the simple default gesture, as shown here, where the word paste overrides the copy gesture. This feature also makes it easier to write these commands on the paper printouts. We have presented PapierCraft, a system that lets users manipulate digital documents by using printouts as proxies. While our current prototype focuses on active reading, we believe that PapierCraft can be easily extended to a wide range of activities where paper is still used extensively.
Okay. Here we are. Okay, so as you may have seen, there is a lot of similarity between PapierCraft and Scriboli, and in fact is also related to another work I did in collaboration with Ken Hinckley called stitching. And one can see PapierCraft as a paper-based version of the stitching system. So how does it work? So it's very simple. Again, it's very similar to Scriboli. We assume that you have a way to switch mode, either with a button or on the side, a pedal below your desk, or maybe a common button on the pen. And then you use a common structure very similar to the one described before, which is you will have to construct your scope by using, for example, in this sample case, this cropping mark. Then you will use the pigtail to delineate between scope and common selection. And then we will use a basic sample marking menu for you to select the kind of command you want. Okay, so we provided different kind of stroke which are compatible with the basic activity of reading. For example, the crop mark, the fact that you can circle a piece of text, you can have a margin selection too, you can underline text, all that are understood as normal scope for command. We also, as shown in the video, provide support for being able to stitch two pieces of paper, meaning that right now you have a post-it note on this document, and after stitching you will be able to see this post-it note on top of the corresponding digital document. As I say, in fact, stitching was a great inspiration for our system, and we in fact use many of the technique developed by Ken in his paper in 2004. The basic command have been shown in a video. I will rapidly go through them. You have exception, which is copy and paste. One thing that you want to note here is that when you do the paste part, is that you have to clearly indicate the area on which the information will be pasted, because of course it's not like in a display where you will see the content right away. So you have to say this area is in fact, scale the information to fit this specific area. And this area will also let you remember that there is some piece of information here, while the context, probably your note, will let you know while you are on the paper what this piece of information is. We provide also copy with 2 arguments, which let you select a specific keyword. We also provide hyperlinking and stitching, as I say. And all these commands really reflect what people do on paper. As I explained in the beginning, they copy information from one article or to the other, or copy from an article to their note. They establish link by making reference in their note, and they sometimes glue information on, do a cutout and then glue that on their note. We also provide a slightly more complex set of commands. The first thing we discovered is that marking menu in its simple implementation only offers 8 possible commands, and we felt that that will be limiting. So what we did is that we provided a kind of escape mechanism, which is that when you mark east, in general that means copy, but if you start writing a word just after that, we will interpret the word as the name of a command. So for example, on the right, we write paste, and it will override the copy meaning of this gesture. In fact, you don't have to write the complete word. You can just write a prefix that is unique, and then the system will interpret this information. Text is also used in different kind of command, like tagging, because people really sometimes want to know that a specific paragraph in a text, for example, is related to a specific project or should be saved in a specific folder in their information retrieval system. So we provide a tagging mechanism. And then we also provide a system which make it easy for people to trigger a set of action, like, for example, underline a block of text and then ask for a Google search on it, or highlight a specific segment of the text and then ask for the system to email the information to someone else. Of course, the main problem with this system is what do you do with error? Because remember, in this system, all the interaction are performed on paper, and the only feedback you get on paper is the ink laid by the pen on the paper. So what did we do about that? The first thing we did was to note that, in fact, on paper, people seldom erase information. They just reissue the command. So that's something that our system allow you to do. You can either reissue a command, or you can use this scratch gesture to, for example, undo the last part of the scope which has been made here. What we do also is that we are very careful to do that. When you synchronize everything, we are lazy in fixing error, because most of these action maybe will not be needed really, because they have been made for the people to remember, but maybe the fact that they make the action will be enough for them to kind of remember that this, a specific piece of paper is related to another piece of paper. So it will be very silly to, when you synchronize, to have basically all the possible error presented to you for you to correct them. Instead, what we do is we are lazy. So when you synchronize, in fact, nothing much will happen. You will see your note, and then you can go through your note and discover what you did on the paper world. If you discover that there is a problem, what is very important is that maybe the recognition mechanism is not accurate, but the capture of stroke is very accurate. So if you discover, for example, that the paste operation did not work very well, you click on this stroke, then we will present you in context the couple of strokes which has been made before. And clearly, the stroke which has been made before are probably the information that you wanted to paste at this location. So it's very easy for you to say, oh, that's the information. We present this information to you, and then you can either say, oh, it was really this information I wanted to paste, or, oh, I did the wrong command, do another command. This approach is in fact very similar to Wikimoto time machine system. Yet, with all that, our users still felt uncomfortable, and so we had to kind of address this problem and figure out how we can provide some kind of feedback to our users. So we focused on three types of feedback that we thought was very important. The first one is status, what is the current selected color, or what kind of error I am making by making this specific selection right now. The second problem is how you can discover the interface, because currently in solution like Anoto, the only way to discover the interface is to be sure that you do not forget a small card which describes the interface. And we were also interested in some small feedback mechanism for simple action, like for example, search a word in a printout, or maybe find the definition of a word. Okay, so we look at what was out there, and two things were seem to be quite important. First is a fly pen, which is a toy built by the Leapfrog company, and I can show you, I can circulate that, which managed to do all its interface through a sample drawing and voice feedback. So it seemed that, of course, doing everything through voice feedback has a lot of drawback and it's slow, but nevertheless it provides you with a lot of interesting semantic information. So if you want, for example, to find the meaning of the word, it will be a very convenient way to do it. Another thing was the haptic pen presented at WIST 04, which showed that you can very reliably create a haptic interface and feeling in a pen. What we tried to avoid was the heavy-duty approach, if I can say so, which is having using a computer nearby, because one of our goals was to be sure that we can do all this interaction without a computer nearby. So we built this pen, which basically is an Anoto pen built by Logitech, which streams information to a computer, and this computer in turn either create sound or voice feedback, or control two actuators, which are vibrator, which are on the top, and control a couple of LEDs on the tip of the pen. So you may say, oh gee, you are using a computer. Sorry about that. So you are using a computer, so it's certainly not a pen top interface. But in fact, what the computer does is very simple. It's just small interpretation of stroke, maybe detect a pigtail, detect the direction of the stroke. So it's clear that this kind of processing can easily be done in a pen like the Leapfrog pen. Okay, so what did we do as an interface? So for the discovery interface, we basically start this interface after 500 milliseconds. And what will happen is that after 500 milliseconds, when you start the pigtail, after you start the pigtail, sorry, what will happen is that when you move the pen, you will discover this interface. So the pen light, the LED on the tip will change color. Either it will be orange for the non-principal axis or blue for the principal axis. When you go from one to the other, you will feel some vibration, which tell you there is an ambiguity zone in between these two axes. And you will also hear the name of the command, so that you can discover which command will be selected if you were to leave the pen at this point. We didn't use more than two colors because we discovered during preliminary testing that in fact it can very rapidly be confusing. And it's in fact better to have this sample mapping, which is primary direction, non-primary direction, to help user when they become expert. So why is that? So let's see the expert interface. So in the expert interface, which is in play within the first 500 milliseconds of command selection, we only render the vibration. So basically what we do is we say, you are in an area where there is some ambiguity on how this command will be interpreted. And then when you leave the pen, we tell you the color which we think were selected. So it can be either non-primary axis or primary axis. So the way it works is that if you make a rapid mark and you have no tactile feedback, then your mark is unambiguous. You look at the mark, that will be what the system will do. If you feel some tactile feedback, you just look at the LED that will shine a color, and then the LED will tell you either I am on one side of the ambiguity or on the other side, and then you decide which one you want. Okay. Yes, this thing has voice and music feedback. Okay, so what did we do now for the more advanced interface? Which, as an example, we use search. So the way it works is that you first underline a word, and then you say search. And the way we will work with it is that we will use the voice interface to tell you, go to page 5. Then when you are on page 5, you will basically, I'm really sorry about that. Let's keep doing it. When you are on page 5, you will simply use your pen and go through the document, and the LED will tell you where the word is. And it worked very well. It worked surprisingly well. And people can find word very easily. And a lot of people told me, I wish I can have this system, because sometimes I really search a word in a document, and it's very difficult to do. Okay, so what is the status with PapierCraft? The presentation here was based on a batch system, so that you have to synchronize your pen. But in fact, now we have a system which can work in batch mode and also in real-time mode, so that you can reconstruct the information as you do it. And in particular, you can interact between paper and a tablet PC. Right now, you have to use 2 pens, which is granted not very convenient, but it would be a very simple matter to have the Anoto pen extended with something that can be tracked by the tablet PC. It has also been used in a joint project called Butterfly Net in Stanford. About the pen feedback, we have run a study, and in fact it showed that we are quite successful in the sense that it does help novice discover the interface, and also help expert users reduce the number of errors they are making while interacting on paper to a level which is in fact similar to the kind of error they can make on a tablet PC. Again, I'm skipping on the detail, and you can look at our accepted but not yet published paper in WIST. Okay, so what is the future work? The future work will focus on evaluation. What we intend to do, and in fact that goes in the direction of one of the questions, is to combine CrossY and Scriboli and to build an application like OneNote, and then to see how people can use this approach in a more realistic environment from what we have now, which is a more kind of prototype style. About the PAD system and PapierCraft, we are starting to do evaluation, both in a classroom with a collaboration with UW, and also with Knowledge Worker with a collaboration with UCSD. If I have more time, I can show you also something quite interesting, which is an extension of this system to 3D, where you can annotate things on 3D object, either made of paper or printed in a 3D printer. And that's a collaboration with my student and Odd Lipson, which I met last year at the faculty summit. And so I can show you the video. Let me conclude, and then after that I will show you the video. So what I described was 3 interfaces that tried to bridge the gap between the kind of interaction you have on paper and the kind of interaction you have currently on a system like tablet computers. And I really hope that this work will really build the foundation for us to understand how we can seamlessly integrate these 2 media. And to finish, I would like to acknowledge first and foremost the support from Microsoft, as I said in the beginning, support from NSF and many other companies who sent me a lot of hardware. And all my students, including George Apitz, which was the first author on CrossY, and Shunyang Liu, which developed PapierCraft, and Yingyang Song, who developed ModelCraft, that I will show you the video in an instant. I would like to thank also Ken Hinckley, with whom I have a very fruitful collaboration and a very long discussion on email. Mary, which always have been very supportive, and John, who is always receptive to my proposal for research and don't laugh at me when I tell him what I want to do. And of course all my colleagues and friends. Thank you. Sorry for being a little bit longer than expected. So do you want to see the video or?
Maybe let people leave.
Yeah.
People that want to stay.
Yeah. Yeah. Sure. Go ahead. It's okay. Don't worry. Go ahead. Yeah. Any question on the last part?
Do you play much with the actual feedback, sort of the profile, like right now you have something very simple, do you explore that space at all?
Yeah, so we describe that in the paper, but the short story that I've played a lot with tactile feedback, and to tell you the truth, it's kind of frustrating because it seemed very exciting in the beginning, and then when you try it, you discover that, in fact, it can very rapidly be very annoying for users. Because imagine having something vibrating for a very long time in your hand. It is very uncomfortable, and people don't like it. So, in fact, in another project, which was document navigation, I tried to do what you say, which is to have some kind of, as you go closer, the vibration is stronger. And people just don't like it. It just kind of, why is it vibrating for so long? And then, it can.
So the users put the thing in the state that you really don't want it to get. That seems natural.
Yeah, but I try many things. I tried, something like that where your target is here.
Right.
And I try also something like that where your target is here. So that's the intensity here.
The second approach makes more sense to me, right? If users find it really annoying.
Yeah, the problem is sometimes it's very difficult to find this low point. So what they do is that they will go, first, there is two problems with this approach, is that most of the time it's vibrate, so it's not very comfortable for users. And they found it relatively difficult, in fact, to figure out where that is. And for this guy, again, the problem is when you are trying to figure your target and you're kind of going back and forth, what happens is that the thing is vibrating and you keep vibrating and you keep vibrating, and at some point they just give up. No, it's true. It's very. So we went for the. It's why during the search we use the light, because light they don't care. It's kind of, yes, it's bright and it doesn't matter. But that they kind of say, no, I don't want this.
It's been well shown that the tactile vibrations you never get used to them.
Yeah, it's very.
You can never ignore it.
Yeah, it's true. It's pre-attempted. I do agree with that. But in fact, we use that in the sense that we use them, which we use small vibration, which really are focusing on catching your attention. And then after that, when we catch your attention, we use another modality to tell you what the problem. So in the expert interface, we catch your attention with the vibration. Then you look at the light on the top of the pen, and it will tell you which side of the ambiguity we are in. And I think people find that easier to do because it's also very difficult to make a distinction between different kind of vibration. I don't know if you have tried that too, but people have a very hard time figuring that out. Any other question? No? Okay, so I will give you the short.
Is a system that captures annotations from paper-based models. When the strokes are transferred back to the original model, it is interpreted as commands and is executed, like in this example, to create modifications to a house. Starting from a 3D model in a CAD program, PapierCraft creates a 2D cutout pattern by unfolding the original 3D model. The 2D cutout pattern is then printed on a sheet of digital paper, which is then cut and assembled. Any surface of the model can be directly annotated using Logitech IO2 digital pen, which contains an internal camera at the tip, translates the unique pattern of dots into sequences of 2D coordinates. When the pen is synchronized, PapierCraft, which is an add-in menu of this CAD program, renders the annotation on top of the electronic CAD model when user selects Download. For cut-through edit command, First, draw a shaped hole. Then, draw a pigtail and a letter C for cut. After the strokes are executed, if the user is unsatisfied with the initial shape, user can modify it in the CAD program and recompile the operation. The starting point of a pigtail indicates where to cut. In this case, the corner should be chopped off instead of the main body. Also, notice how the character can be written in arbitrary orientation and location. This is possible because we use the pigtail as a baseline for character recognition and as a callout. Each feature can be reversed to every stage of the execution. The house can be rolled back to the original cube or to any middle stage. The simple syntax can also accommodate several parameters like depth of the cut. First, the user draws a shape of the cut. Next, the user marks the depth of the cut. Finally, draw a pigtail and a letter C. In addition to basic cut operation, we allow the user to groove as well. Shape parameter in this case is semi-closed shapes on 2 or more adjacent surfaces. In this example, 3 groove command has been issued to a cone. Here we show extrusion by extruding a section of the cube face to fit around a door frame. After tracing the door frame, we can mark the extent of extrusion on a digital paper ruler, followed by a pigtail and a letter E for extrusion. We see the extended cube result in the CAD program. Our command system is flexible enough to provide a wide set of features. Here, we execute fillet operation on an edge and a shell operation on a face. This example creates a rounded container from a cube using 4 fillet, 1 shell, and a cut operation. To summarize, ModelCraft can shorten iterative cycle of model construction, modification, and rebuilding. It will pave the way for new interaction with 3D models for prospective users such as architects and mechanical engineers.
Any question about that?
I wish I had that when I was trying to figure out all this for my house.
That would be perfect, right? You can just draw it and then it's done. Okay, great, thank you.